Here's our first example of a linear equation in one variable. It's an equation. We know that because of the equal sign. It's linear because the variables have 1 as their exponent, and there is only one variable. There's only an x. There's not a y variable also in the problem, or a z, or some other variable. So this is indeed a linear equation in one variable. We're going to follow our steps that we have in our procedure. So we're going to look first at fractions. We're going to see, are there any fractions in the equation? And there aren't. We're already past that step. We're going to go to the next step, parentheses. Frantic partiers, parentheses, partiers. Are there parentheses? Yes. Then we're going to use the distributive property to remove those parentheses. We're going to distribute the multiplication of 3 times both of the terms that are in the parentheses. 3 times x gives us 3x. 3 times plus 2 gives us plus 6. Frantic partiers excitedly, expressions. We're going to look at the expressions now and see if there are any like terms within the expressions that we can combine. These two terms are not like terms. We can't combine them, so we simply write those two terms down again. But here we do have like terms we can combine. 3x plus 6 minus 5, the plus 6 minus 5 combines to plus 1 when we combine those like constant terms. Frantic partiers excitedly open. Only one variable. We have 2 variables. We want only one variable. So we need to remove one of those variable terms. Let's remove the 3x term. That's typically done by performing an addition or a subtraction to make that term disappear into 0. In this case, that would be done by subtracting 3x from 3x. That makes that term disappear into 0, leaving us just 1 on the right-hand side of the equation. Now remember, there's a fundamental truth about equations. Equation says 2 things are equal, which means it's as if we have a balance there, an old-fashioned seesaw, an old-fashioned teeter-totter. This value over here balances out that value over there. Whatever's here on the left side is exactly equal to what's on the right side, but we just took something away from the left side. So to keep our equation in balance, we have to take the same quantity away from the right side of our equation. 4x minus 3x would give us 1x. Or x, remember? No coefficient written for a variable term. The understood coefficient is 1. So we've gotten rid of any fractions that were there. Fortunately, there were none. We've removed the parentheses. We combined the like terms in the expressions. We're down to just one term that has the variable. Now we want to isolate that variable term. In order to isolate this x term, I have to get rid of the plus 10 term. And that would be done to make that disappear into 0. I would subtract 10. But again, because an equation is a balance, whatever's being subtracted from one side has to be subtracted from the other side to keep that seesaw still in balance. You know, you kick one kid off one side, you got to kick somebody the same size off the other side to keep it back in balance. And 1 minus 10 gives us negative 9. Now we want to make sure the last thing is the coefficient. Is the coefficient of the variable 1? Well, fortunately here it already was, so we don't have any additional work we have to perform. And we have found that the number that will make the left-hand expression identical to the right-hand expression would be the number negative 9. In other words, if we take negative 9 and put it here in place of x, put it here in place of x, the value of this expression will become identical to the value of the expression on the right. Let's test that and see if that would be true. Negative 9 plus 2, well, that'd be negative 7. 3 times negative 7 would be negative 21. Negative 21 minus 5 would be negative 26. So when x is negative 9, this expression has a value of negative 26. Putting negative 9 here, 4 times negative 9 is negative 36. Negative 36 plus 10 is negative 26. So indeed, when x has a value of negative 9, the left-hand expression's value is identical to the right-hand expression's value. That's what it means to find the solution to any kind of equation. Any kind of equation you have, when you have found a solution, it will make the left-hand expression's value identical to the right-hand expression's value. And our problem is done.